I'm going to talk about the marginal value of airport slots at congested airports. And this kind of came out of some work I was doing with students that okay, I'm being technologically challenged this morning. So one of my students came up and said to me, so it's working, it's okay, I just had to turn it on. Thank you. Why are slots free? And I thought, but well, 1 minute, there aren't really slots at most of the US, so what would the value of a slot be? And so we kind of started from there, and we looked at the US markets and the European markets, which define an unregulated and regulated system. To be honest, we wanted to look also at the Far East, because they have a very interesting system in their own right, where slots are not just set per hour, but in fact set according to whether the flight is domestic, regional, or international. So it would have been really fun to look at all three. But as you will see later, we were very data challenged. So despite living in the world of big data, we had to work over a year just to collect this little data set. So I'm going to sort of show you the picture from the literature of what we see, and then move on to a couple of models that we've used to try and evaluate the value of an additional slot. So we're talking seriously marginal here. We're talking about, say, an additional slot per peak hour, and only at very seriously congested airports. So the group from Maryland and Berkeley and MIT, together called Next Door, have a very interesting paper from 2010 where they were trying to figure out how much the delays that were generated in the US were costing the US as a function of the lack of regulation, essentially, of slots. So they stated that in 1986, about 1,100 flights were delayed per day and for more than 15 minutes. By 2007, that was nearly 1/4 of all the flights in the US. And their estimation of the value to, or the cost to US society, was in the region of $28 billion US. So not a small amount of money. Half of that was attributed to the passengers, and about $8 billion to the airlines. That would be the cost of the delays, both direct and indirect. What goes on in Europe? Well, as we discussed yesterday, there's the technical capacity as a function of the runways and the terminals and aprons and whatever's restricting the individual airports. And then there's the actual declared capacity. So at all of these airports that we're going to look at, level 3, they're all restricted on an hourly basis. And we can see, for example, at Schiphol, the technical capacity, according to, this is from the European Commission report in 2011, there were 615,000 potential movements per year, but it was restricted partially or mainly for environmental reasons and noise reduction reasons to 510,000 movements. So my argument is that it would be possible to perhaps add a couple of flights without too much, at least technical difficulty. And we can see, in Düsseldorf, it's the same story, and this is the government that's decided essentially what the capacities should be. We can see in Linate, it's very restricted. This was to encourage airlines to use Malpensa, protect Alitalia perhaps. Every country is looking at its own airlines and its own airports and trying to protect its industries. It's, I guess, understandable. But what we can see here is definitely no sweating of assets in Europe. And from this same report, I think we have a very interesting highlight of what goes on. We can see in the top two graphs, Heathrow, and in the bottom two graphs, Madrid. And you can see for the arrivals and the departures, and the red lines are the caps. I do not believe that the grey stuff above those caps, which is the demand or the requests by the airlines, are in fact the real demand. I think most people don't bother to apply for slots at Heathrow, and yet you can still see that the demand is still substantially above that cap. In Madrid, it's a sort of simple red straight line, But it's the same story. Yes, there are banks here. These are hubbing airports, and there is clearly more demand than the declared capacities. And finally, there is this really interesting description by O'Donoghue and Morissette. What they did was they compared Frankfurt and Newark, a bit like we saw yesterday with Mexico and Schiphol, yes. So we can see that Frankfurt in 2007 had 54 million passengers, Newark 36 million, so substantially less number of passengers. Number of movements slightly higher in Frankfurt. Number of runways exactly the same. 3 runways at each airport. The passengers per movement are way higher in Frankfurt. In other words, the aircraft are larger, the aircraft that are used in Europe. And then we have these 2 beautiful graphs on the right-hand side. The blue line are the scheduled movements on average for that year, and the red lines are the actual movements. So we can see that for Frankfurt, those 2 graphs are fairly similar. We can see, however, for Newark, that the actual movements over the afternoon are way below the scheduled movements, and so that crosses, and then in the evening are all the flights that were delayed. The bar charts, the red and the green, display the delays. Red is for arrival delays, and green is for departure, taxi-out delays. In Frankfurt, throughout the day, it's in around 10 minutes. For Newark, you can see these 2 waves. In the afternoon, average delays for departure and taxi-out, over 60 minutes. This is a choice. So the Americans choose to leave things unregulated, and the Europeans choose to regulate them. To be fair, in 2008, they already started hitting Newark with the high-density rules. In fact, there are 4 airports in America that are capped or ruled, which includes the 3 in New York and 1 in Washington, Reagan. What we learn from this graph, I think, is basically that there is a trade-off, okay, between delay and regulation. And perhaps, or at least this is what I thought before we got some results, in Europe, those caps are too low. And perhaps we could survive a little bit more delay, utilize better the airports, and theoretically maybe everybody would be better off because more flights also give more choice to passengers. And the airports could make some more money, and airlines would be flying more people around. And maybe in the US, it's insufficiently regulated. So Swaroop and the group from Maryland argued that the airports with high-density rules should have their caps reduced, and maybe some of the other airports should start being capped because they measured the cost in 2007 at $30 billion, which is not a small amount of money. So we set about trying to figure out whether we could find that balance. So we're going to look at the impact of changes in slots on the airlines, on the airports, and on the passengers. So try and look at overall social welfare. We did this in 2 stages. We first used a structural equation model. The reason that we did this is basically regression. And what we were arguing was it's very difficult to actually measure the capacity of an airport. A lot of factors impact it. Different airports have different factors. So we can describe latent variables using this approach and then look at the connections between them using a path model. So we could watch how the changing capacity could impact delays and impact, say, the financial outcomes of an airport. And then we can use that information in a second stage analysis and try to evaluate the impact on the airlines and on the consumers. So when I say consumer surplus, that's a little bit more amorphous than anything else. So in social welfare, we're talking about airport profits, airline profits, and then consumer welfare. And basically what we have here on the x-axis is the demand, the passengers, and on the y-axis money. And we have 2 curves. So our demand curve, which is downward sloping because the cheaper the price, basically, the more likely there is to see a growth in demand. We have an average cost curve. And we're arguing that the airports in our story have a capacity, Q1. And if we add a little bit to that cap and move to Q2, prices will come down a little bit, more passengers will travel, and the blue part of that story measures the additional consumer surplus gained from that change in the capacity. Okay, so that's the second stage story. Okay, so now I get to the case study, and we're going to compare European Union and the US. And we started with sort of 15 airports each, but then life is never as simple as you think it will be. And in fact, 2 of the American airports turned out to have very little connection between delays and capacity. So we lost Dallas, Fort Worth, and Detroit, because simply they're not capacitated in the way these other airports are. So we have 13 US airports. We have slightly more European airports. Some of them are only peak period capacitated. Okay, so like my home airport, Tel Aviv. Okay, so this is the information that we collected on the airports in order to start trying to estimate the value of the slots. So we started with capacities. Well, in Europe, for these airports, it's easy because we can just collect the information on the declared capacities. But what were we supposed to use in the US? So the FAA gave us a very pretty couple of pieces of information. They showed us what are the capacities of the US airports under VFR and under IFR, or at least that's what I called it. So under good weather and under crappy weather, okay? Some of these airports, there's very little difference between the two, say Atlanta. Atlanta kind of enjoys nice weather, I guess. Some of them is quite a large difference. So for example, Dallas-Fort Worth there, you can see it drops to below 200. Normally it's closer to 280. Okay. In America, no slot restrictions. The airlines basically just assume nice weather all the time. This is why we see the delays building up when there's bad weather. Okay, so we used this information from the FAA to define the capacities at the individual airports. Then we also wanted to look at the terminals. So we wanted to look at, say, the square meters available for passenger throughput. It's very hard to get this information such that it's standardized and correct for all airports. So some don't include the parts that are offices behind and so on and so forth. So we ended up just counting gates, both at the terminal and the remote gates. No, I'm talking nonsense. That would be aprons. No, there are gates. So if you have parked your aircraft further out, then you're going to take a bus and carry your passengers there. So it's the total number of gates. We're also going to look at the peak and the off-peak season individually. So we looked at collected data on February and August for air traffic movements and for passengers. Then we get to the delays, because we need that, because otherwise we don't see the trade-off. This is not so simple. This is the stuff that's hard to get. It comes from Eurocontrol in Europe, and it comes from the FAA in the States. We looked only at the delays above 15 minutes beyond the scheduled time. And finally, the economic data for the airports, which includes both the commercial revenues and the aeronautical. Those are coming from the airlines and those are coming from the passengers. And then in the US, there's this passenger facility charge. So when you buy an airfare, there's the base fare and the additional charges and taxes. In the US, that includes a fee that is given to the airports if they ask for it. And so in order to be comparable, we collected that information and added it to the revenues of the American airports. And finally, we have the costs, staff, other operating and fixed costs. Okay. So here we can see, so we collected data from 2002 to 2013, and what we've done is average it for the US and for the Europeans. And we can see, first of all, for the US, VFR is 141 units for an average airport in our sample, which goes down to 110 if you're talking about bad weather. In Europe, it's 75. So in other words, the Europeans have a much lower runway capacities, declared capacities. The gates, on the other hand, are very similar. So I think the terminals in Europe are bigger They're more of a shopping mall. They have more space for the passengers and so on. So similar size gates. Then we get to air traffic movements. So the US airports here have almost double the number of air traffic movements compared to the Europeans. Okay, almost double, but only 1/3 more passengers. And the reason for that, of course, is that in the US, they're using smaller aircraft and a lot more regional jets than they do in Europe. Okay, so we get to delays, average delays in minutes. The gap is around 3 to 5 minutes. Lower in Europe versus the US. In Europe, it's higher in February than in August because of bad weather. In the US, it almost makes no difference. And the last column is the most stark column. Airports in the US are public entities. They are not for profit. And you can see that in their EBITDA, which includes the passenger facility charge, which is around $1.5 million, compared to the European, which is on average, for an average airport over this time frame, all data has been PPP to 2013 US dollars. We're talking about $261 million on average in profits for the European airports. This, of course, adds expenses to airlines in Europe that mean that the CASK of European airlines is 1/3 higher than the American airlines. The differences are quite stark. So here's the results of a SEM, structural equation model, for our airports. If we start on the left-hand side, at the very bottom, we have what we've called airside capacity, so our declared slots. And at the top, the terminal capacity represented by gates. They each feed airside and terminal side activities, which then feed both the financial activities of the airport and the negative externalities, which in this case are just the delays. The numbers that you can see are standardized coefficients. The higher they are, the more important that connection is. We can see, for example, that airside capacity has substantial impact on the throughput at these airports, whereas terminal capacity has a much weaker connection to terminal side activities. Equally, we can see, if we look at the capacities, the higher the capacity, the lower the delays. Therefore, the connection here, minus 0.232, is negative. On the other hand, we can also see that airside capacity feeds airside activities, and basically that 0.866 means that if you increased the airport's slot by 1 unit, there's an 86.6% likelihood that there will be a new movement, okay? Because of course we're talking about peak and off-peak here. When I wrote Europe in peak, I meant Europe in August. I should change that. Okay, so there's an 86% chance that you're going to get an additional movement, and if you get an additional movement, it is going to substantially add to your delays. 0.945 is much stronger than the minus 0.232. So overall, if you add a slot, you're going to increase your delays at these congested airports that we're looking at. Furthermore, you can see the terminal side and airside activities feeding the finances. And we see here that the passengers are more important, approximately double more important to the airports in terms of revenues. So in Europe, both sides are paying large sums of money. The passengers are more important for the final profit, the EBITDA. In this story, what you can simply see is the August versus February. They are very similar. So in other words, we ran 2 sets of regressions. We've been using bootstrapping to make sure that our results are consistent. And we can see that the results are fairly similar. And then we can look at them compared, for example, Europe in August to US in August. And there we can see some slight differences. So, for example, airside capacity is feeding the negative externalities in the US at a much stronger negative coefficient compared to that of Europe, but equally, there's an 87% chance you'll get an additional flight, and that feeds the delays even stronger. The other startling or point that we should note is the airlines are not covering the costs of the airports in the US. The connection is negative and significant. It's the passengers that are feeding the financial activities at the American airports. So to some extent, there's a cross-subsidy there, more than there is in the European system. In other words, if the American airports earn some money from the passengers, they then have to reduce their charges to the airlines, because in total, they have to make zero profits. Okay. From a SEM, you can create a computation of the total path effects. So for example, from airside capacity, what is the impact on delays? So we said in one way it's positive, in another way it's negative. The total impact is positive. So at these capacitated airports, if you increase the movements, you're going to end up with more delays. Then you can see air traffic movements to profitability. They're both fairly weak, but in Europe, it's equivalent to about $13,000, and in the US, just 2. It's even more startling when you look at airside capacity to profitability. So in Europe, the airports are making money, and in the US, they are not. Why do we care? So what I'm going to do is use these numbers to try and evaluate what it means for the airports, the airlines, and the passengers. And what we're going to do is in Europe, add a slot. One slot for a 12-hour like peak hours out of a 24-hour day. That would mean a total of about 4,300 additional slots per year for an average capacitated European airport. And we're going to do the same for the US, but we're going to take a slot away and see, is society in general better off? To do that, we needed airline information. We need passenger information too. I'll talk about it. So the airline data that we collected, we can see here in the top graph, load factors, RASK, which is the revenue per available seat kilometer, and CASK, cost per available seat kilometer. The European airlines have slightly lower load factors, but nothing substantial. The RASK, on the other hand, is 8 cents in the US and 12 in Europe. And if you look at the paper, you'll see massive differences in the European market. It runs from 5 cents, I think, for EasyJet, up to 16 cents for Lufthansa. And in the US, it's practically the same for all airlines. I think only Southwest is slightly less in our data set. So you find much more homogeneous airlines in the US as compared to Europe, and with much lower costs. Part of that, of course, is the fact that the airports are making money in Europe and not in the US. Part of it is to do, from what I can see, like all these wonderful duty taxes that have been added in the different countries, Germany, France, England, and so on. These make patterns. You have to remember that this data set, which ran from 2002 to 2013, covers 2008, 9, 10, so the financial crisis. Basically, the airlines are only covering their costs. So their RASK is basically equal to the CASK in this story. Interestingly, within Europe, they do just cover their CASK even if it's higher. So Lufthansa and so on. And then at the bottom, we can see the type of aircraft used. We can see that the European airlines are not using the regionals, using narrow and wide bodies with similar seats and lower distances. So the European market is slightly shorter distances than the US. Okay. What I'm now showing you is the summation of all of this information. Just for Europe, one additional peak flight per hour. For the airports, for an average airport in our story, that's worth around $54 million US. For the airlines, they're going to make about $1 million in additional profits, but they're going to have to pay for the additional delays that we measured through the SEM to value delays in terms of money. We used the Eurocontrol value, which they stole from Cook and Tanner, and it's around 81 euros per minute additional delay when we're talking about small additional delays. It's obviously non-linear when you start talking about much, say a half hour, it changes. Okay, so we're talking only about small increments here, 81 euros per minute. For the passengers, we measured that little blue triangle square that you saw in the previous diagram. Their willingness to pay is based on the RASK, that's what we assumed, okay? Because we have no real idea of what is the value of a trip. So we assume that if they're paying $250 for one way for a standard flight, then that's the lowest value. So it's a very conservative estimate. To measure the impact of the delays, we took Michael Bull's figure of $37 per hour. That's the sort of values of time that he published. In total, if you added those additional flights, the airlines wouldn't be happy because it will cost them more. But the airports and the passengers are very happy, and for our average airport, those additional 4,300 slots per annually are worth around $67 million. Now we're going to take them away from the average US airport. And what we're going to see is the airports are going to be a bit unhappy. Again, this is fairly conservative because what will happen is if they have less flights, they'll spread their costs to the airlines. So every airline would have to pay a bit more for each of their existing flights. They would lose up to 10 million. The airlines, on the other hand, would be very happy. They would save quite a lot thanks to the reduction in delays, even though it's a small reduction in delays of less than a minute. I should add, of course, we have here three numbers. What we did was we estimated the expected one based on the average fleet mix at that airport at that time. If they were to only use regional jets or wide bodies, then those would be the corrected figures, and we can see that they're in the same sign, okay? And finally, we can see that the passengers would be worse off by taking away those slots. So the overall social welfare impact of reducing a slot per hour peak is around 18 million. So in other words, the US are not crazy, and they shouldn't be introducing slot restrictions in the way that the Europeans do, because apparently the Americans are better off the way they are. Of course, a lot of this is very dependent on what is your value of time. But you can triple the value of time, and you'd have to triple it before this story would change. So if you don't think that 37 dollars makes sense, but it should be over 100, then maybe you would have a different story. This is exactly what we were talking about yesterday in terms of the values of service, and where is the balance. So in conclusion, what we could see from the SEM is that it is the runways that are capacitating the airports much more than the terminals, in our story anyway. In Europe, it would be worthwhile slightly increasing those slots. I mean, I might even go as far as to say get rid of them in many of the airports and use the American system. But at least increase them slightly. You can sweat your assets, you can use what you have, and in fact, it would be better both for the airports and for the passengers. So you'd need to make sure that the airlines somehow are compensated. Maybe you'd need to think about how delays impact airlines and what you would want to do with your charges if delays increase. In the US, there's no justification for introducing slot limitations or even reducing the HDRs at the 4 airports that are included in this analysis. And thank you for listening.